All right, everyone, we're going to go ahead and get started on this session. I'm Madison. I work at Green Spaces. You'll see me running around like a crazy person today and tomorrow. But I am here to introduce Aaron Gould. Aaron has over 20 years of international experience in design and construction with an emphasis on health and durability. After several seasons in trades, while guiding climbing in whitewater, adventurous guy. He went on to lead and found design construction consulting business. Aaron is currently enjoying his 10th year with Vapor Shield of Gig Harbor, Washington, and heading up sustainability globally. Examples of his CV projects and experience include mass timber structures, hospitals, hotels, high-rises, mixed use, zero restorations, schools, universities, government facilities, art museums, and the occasional treehouse. Yeah, I like a treehouse. Aaron has a lot of credentials that I am not going to read through. You guys can read them all. But we are very grateful to have him here today, and he is a big-time supporter of Green Spaces and our mission of sustainability. So everybody, here's Aaron.
Thank you. All right, thanks everyone. Hopefully the clicker will work here. Let's see. Oh yeah, there it is. Okay, so I drive around all over the place. Whenever I go to Nashville, I try to take a different way, which, you know, I go fairly frequently, and I think I've gotten about 20 different ways so far. And I take photos of different places that I go. Some of you may know who this guy is actually, but yeah, exactly. But some of these rural, I like how he's dressed in that photo. You know, but some of these rural homesteads and old farms and houses, people are still living in a lot of these places. Some of them are pretty innovative in their laundry machines and other things, but I wanted to highlight some of these people a little bit just because they have a lower carbon footprint than any of y'all, including myself. You know, they drive that old truck right there that gets 8 miles per gallon, 5 miles a week, right? They hang their laundry out on the line, some of my neighbors and yours, and, you know, these guys, I don't know which one of these guys has a lower carbon footprint, probably the one who's flying this one more often. In fact, I didn't even realize, but they fly 2 of those every time they have to go somewhere because our POTUS has to, just in case they, you know, shoot one down, I guess. But anyway, so here's me driving to Nashville. I actually went down this road for 4 miles. It was one lane, and I came up on this little crossing here, and I was wishing I had that guy's truck at that time. Now, I contemplated it for about 15 minutes, and Dave, this is when that big storm was coming through, and you could see the clouds maybe a little bit, but about 15 minutes it took me to talk myself out of it. I thought maybe I could make it, but anyway, I didn't. So these are, you know, you just have to chase these kind of roads that you see around here. We live in a beautiful area, and we have a great heritage, and it's going to be hard following the last speaker who really highlighted some of that in this area as well with the Cherokee. You know, you probably saw Chattanooga right in the middle of her map right there. So what beautiful country we live in. But I'm going to talk about one of our other heritages, and that's our natural heritage of timber. And some of you may or may not know, but the southeastern United States has the third most significant lumber reserves in the world. We have a lot of timber. And believe it or not, we need to use more of it. All right? Forest health actually requires us to use more of it, you know, because you see what's happened out west with the fires, and a lot of that's because we're not using enough wood. That's a little bit ironic. That's a little bit interesting, and that's what we're going to talk about here today. I didn't realize that, to be frank, until just a couple years ago. When I started working with Clemson's Wood Utilization and Design Institute. And I've learned a lot from Pat Layton, who heads up that program, and from others. I'm not really a hat guy, but this is Sterling Manufacturing, is a CLT manufacturer out of Illinois They are the largest producer of CLT, of cross-laminated timber in the world, and that's mainly what we're going to focus on right now. They just started shipping their PRG 320, their structural CLT panels. They make one panel a minute. They are blowing open the market with commodity prices. CLT and mass timber is no longer a boutique building material. It is going mainstream. All right. And if you have any doubts, check out woodworks.org and check out all of the projects that are coming up. We're talking about, I think it's pushing 1,400 projects in North America right now in mass timber. And I've had the privilege of working on quite a few of them over the last few years, and I'm going to talk about some of them here today. Woodworks.org. It's a federally funded Forest Service and industry partnership that is educates about utilization of wood, and it's very helpful for fire and things like that as well. So we'll get to it here. So we're going to focus on building envelope. Now, only about 20% of mass timber buildings actually use mass timber on the walls. Most of them are using them on the floors now, and it's replacing concrete at a great pace. And so we're going to focus on that a little bit more, but we are going to talk about the walls as well, because in this climate, actually really throughout North America, it's a fantastic way to build from a building science perspective. I'm going to blow through a lot of the text in interest of time and kind of focus a little more on the photos and images. They're more fun anyway. This was a project in Miami, the first Miami Dade approved mass timber project. That was a milestone. If we can build them there without any leaks and without any water stains, we can build them just about anywhere. That was a very successful project. So, cross-laminated timber, CLT. I'm going to pass these around, if you guys don't mind starting here. I'm going to pass them together actually, because one of them, the one that's larger that has the 1.5 inch laminates, is Southern Yellow Pine. It's domestic. The other one that has closer to 1 inch, it's like probably 7/8, 3/4 laminates. That's a European. The market's much more mature, but you can just kind of see the difference there. We're mostly using Southern Yellow Pine. It's a little bit different material. It has to be engineered differently than the European ones. You can't just plug and play. You have to really start from the beginning with that design intent of using mass timber. So that's something to keep in mind. And there's a lot of great resources out there at Woodworks, and then we also have a design manual for building envelope that we worked with RDH Building Sciences. But one of the big draws of it is the speed. 50% faster. Redstone Arsenal down in Alabama had the first CLT hotel go up in the U.S. about, 2016, I think, 2015, 2016. It was framed and had the roof on in 6 weeks. And it's incredibly fast if you manage the water well. And that's one of the things I'm going to highlight here today, is that you really have to pay attention to wood's a very moisture-sensitive material. So we really have to pay attention to that. But this saying timber is the new concrete is very legitimate. And I would highly encourage you to take a look at that as a replacement for concrete. We're seeing that whether or not the structure is wood from the posted beam, that might be a hybrid with steel. There's lots of different ways of doing it. And there's lots of different types of mass timber. You have CLT, cross-laminated timber, and we're going to talk about that primarily today, but it can be analogous to the others like DLT and NLT. NLT's been around for a long time in the U.S. in particular with car dealerships, multi-story car dealerships in urban areas. Tacoma, Washington has quite a few of those. DLT is growing. There's a new DLT project up in Nashville. There's T3s in Atlanta, and then there's about 20 more to follow that Hines is developing. They're one of the largest developers in the world. They're building those at what they would normally lease out for $28 a square foot, and they're leasing them at $39 a square foot to clients like Facebook and others. They're making Class A office space out of this, and it's getting gobbled up. It's wild. Glulam, you guys are probably familiar with, same with LVL and the LSL, and then also Mass Ply MPP panels are not showing up there. Our technical director, Vapor Shield's technical director right now is building his own project this week. They're erecting it in Washington on Whidbey Island out of NPP, which is pretty cool. Freris Lumber in Oregon. It's basically massive sheets of plywood. You know, if you can think about like a 4-ply 1/2 inch CDX, with 10 of those stacked together. That's basically what he's building out in Gould. So that's what MPP looks like. But CLT is probably the most popular and fastest growing. DLT has some great fire characteristics, and that's big. And also some people like Heinz, they like the aesthetics of it. So that's growing as well. But I want you to notice here that we have a lot of varying climates compared to Europe. And in Europe, we've been importing the European, that's a spruce one that I passed around there, which is more moisture sensitive than southern yellow pine. And what we're also doing, not only importing the woods from Europe, but we're importing some of the techniques of how we build them. And we really have to refine and really own the way we do it here. And here is that, by the way, here's just a little graph showing the growth of it. And by the way, look where it is. I wonder if this laser works. Oh yeah, sweet. You see that? Look at the concentration in the Carolinas, Georgia, and Tennessee of how many projects are in design or construction. There's a lot of them. And Florida as well. Look how many are coming up in Florida. Once we finished that one in Miami, it was like, stack up the dominoes. They're coming. So I'm working with several architects down there on that. The whys for mass timber, besides the carbon and others, I mean, it's pretty obvious. It's a beautiful material. But from a building science perspective, I just want you to understand that having all that mass in there that also insulates to some degree as well, softwoods are about R1.2 per inch, is really a very unique material. It also has a great ability to absorb and release moisture. It can help regulate humidity levels. It actually eliminates any need for a vapor retarder because it actually is a vapor retarder itself. Which is a complex subject matter that we can get into if you guys want to talk to me about that. But wood, it is a vapor retarder. It's not a vapor barrier, but it's a vapor retarder. It slows down and it buffers that and becomes a throttle for vapor movement. So this is just what we want to do. We want to protect the wood. But if we, as far as the carbon is what's driving this, in a lot of, for example, Microsoft right now is building campus buildings out of mass timber. They're trying to their goal is to be carbon neutral by 2030 across their supply chain. So they're also doing that on their campus. And but if you don't protect it, if you don't do well, you lose a lot of the advantages, and you end up your carbon calculations can actually be thrown off if you don't protect it well. And I really like the concept of protect the bank. I stole this slide from another presentation that I have on that subject that is on sustainability in general, but I really like this concept of buildings as material banks. I want to think about buildings and protect them well. And what do you do with, obviously with banks, you have to protect the assets that are inside of those. And we want to do the same thing with buildings. We want to make sure that we're protecting them well. And we do that primarily with good building science and good design. And just want to show you what kind of scale we're talking about here with mass timber before I get into some of the technical specifics about it. And I'm probably going to run out of time here, but as mass timber grows, it gets bigger and bigger, and you can see these massive wood decks that essentially are roofs as they go up. But it gains a lot of risk as it gains exposure. I'm borrowing a climbing term there, if any of you climb. That I really want you to kind of grasp that as you stand on the edge of a big cliff. Like, that's what you should think about when we're building these bigger and bigger buildings, because it is extremely risky. And I've got a study for anyone who's interested that was done in Sweden on the mold growth potential in wood buildings, especially if they're not protected well. And mass timber is not immune to that at all. In fact, that study was specifically about CLT, and they took a lot of samples of it. And it's a very fascinating and very worthwhile read. It's only 8 pages. But wood really shouldn't get wet. It shouldn't. Thank you. Is that better? All right. So we all know what happens when wood gets wet. And horizontal wood, of course, has the potential to collect a lot more water than just vertical wood, and even while it's staged. So we want to pay attention to this and keep this in mind. And I'm going to go through a lot of these slides really quickly, so feel free to ask me questions afterwards. And I'm going to come back to this concept of wood floors as roofs, right? And we're not talking about shingles here. This is just what happens when it goes up. So that's we'll detour back to that after we touch on the building science. It's really the same with other buildings. We want to keep what's called the control layers, the air control, the water control, and the vapor control, to the outside of the structure or wherever possible. That's just kind of a low-hanging fruit, fairly easy way to build. Now with cavity construction, oftentimes you want to have some acoustical insulation in the cavities as well. But with mass timber, you have quite a bit of insulation characteristics with the softwood, like I mentioned before, R1 to R1.2 per inch. So if you have, a 7-ply wall, you got a pretty significant amount of R value there. But you still need to, in order to bring it up to code, generally speaking, in most places in North America, you need to have some insulation on the outside. You also need an air barrier system as well, and it needs to be vapor permeable. You have to use vapor open materials. We've already seen some failures with mass timber from both liquid applications and from non-permeable applications, and I'll talk about that in a little bit as to why. So there's a lot that buildings have to manage. You also have to consider fire and smoke development and insects. On the project in Miami, for all the treated lumber that was used on the exterior portions of the building for other purposes, they actually saved all of the sawdust and sprinkled it around the perimeter of the building to reuse that material to help deter termites, and that was very successful as well. In our area, they're not nearly as bad as they are down there. Wood typically has to be moist in order for it to be attractive to termites. So if you keep it dry, you're miles ahead, and that's something to take home. So as far as enclosure design goes, the way I like to summarize it is by the 4 Ds: deflection, drainage, drying, and durability. So the exterior cladding, roofing, flashing elements, those all provide deflection of the bulk water. They handle 99% of most of the water that comes to the building that encounters it. And then what gets past the exterior cladding and other elements needs to be able to drain out. And needs to be able to drain out at flashing and get to the outside. And then also having some sort of ventilation back there, so a ventilated rain screen is very advantageous in the South, especially with permeable membranes. You want to have that ventilation. You don't want to VE those top brick vents, because having that air circulation back there, especially with reservoir claddings, mitigates any concern of reverse vapor drive. And again, it's critical that you have permeable materials over wood. Wood has to dry out, and it gets wet. It's going to get wet during transport. It's going to get wet during construction. So these are pretty basic assemblies that you would see. This is actually showing studs on the interior, which is what happened on the Candlewood Suites hotels that Lend-Lease developed because they had to maintain their corporate standards, so they covered up all that beautiful wood. But it's a basic rain screen design with continuous exterior insulation. And here's another one shown with an open joint rain screen. One of the advantages when you have permeable membranes is you can have multiple layers of it, and you can protect that insulation from wind washing on the exterior as well, and then you can have a UV stable layer behind open joints to open up a lot of design possibilities. So here you can see how that water deflects here and drains down behind the cavity. This is basic rain screen design, basic rain screen concept, just like in conventional construction. It's best practice, and in fact, it's in the code now in most areas, and we're finally recognizing it with stucco, thankfully, because there's been a lot of failures, especially with wood frame construction and stucco, and so I'm grateful that code is catching up with building science to some degree. So here's some of the nightmares of what can happen. This is actually structural decay, and we're doing testing with RDH right now up in Waterloo with John Straub and Graham Finch to really see how far this can go and what kind of effects it can have when you don't protect the mass timber well. It's really important that you protect as much as possible from getting wet. And it's going to get wet, so it's critical that it has permeable materials over it. And we actually have the technology to do horizontal protection, that took us about 5 or 6 years to develop to do that, to be able to take the foot traffic and to take the equipment traffic to do that. And it's so we can do that, and it's really good timing because now we have these taller buildings coming, which really attract a lot of water. So air barriers are another thing that are critical. So as far as bulk water, that's the way that most water gets into buildings. The second path is through air leakage. So air leakage is not just about energy efficiency, it's also about managing moisture. And the larger the building, the more factors, the more physics come into play on it. But whichever building you're building, whether it's small or large, and believe it or not, it's actually more difficult to get an airtight building that's small to really achieve air barrier efficiency. It's kind of ironic, but it's a great exercise if you ever get a chance to detail an air barrier system on a tiny house or something like that. It's a fantastic challenge. But any theoretical section view at a compound angle even, you should be able to take that red marker or orange marker or whatever and be able to not lift that up and then think about how those interfaces happen as well. Who knows who can name some of the most commonly missed air barrier interfaces? Any of you guys have ideas on that? How about, yeah. Bingo, that's actually probably number one, is the roof to wall interface. Yeah, the complexity of it, whether it be a parapet or an overhang, there's so many different ways to detail. Sometimes it comes to the interior plane, transitions from exterior to interior. Yeah, that's one of the most often missed. And there's actually been documented failures of buildings from that specific detail, especially in northern climates. And then you also have like fluted decks coming into CMU walls and things like that, really challenging details. So bottom line is you really got to think about it. You really got to pay attention to how you're detailing. Shop drawings are great from contractors. They should hopefully submit, if your specifications should include a request for shop drawings. So the next thing, once you take care of the air barrier, have it be continuous, is to address the insulation. And most of the time it's going to be a fire-resistant insulation on mass timber, high density, like 11 pound per cubic foot or 11.2 pound per cubic foot rock wool or something like that on the exterior. A lot of times you'll see thermally broken cladding attachments as well. And I'm going to go into a few of those and what that might be. But the fire is, something to really pay attention to with these. But believe it or not, they perform pretty darn well in fires. There's been a lot of testing on fires, and there's actually some great seismic testing, full-scale seismic testing going on right now. And so far, the results are very promising for that as well. That's beyond the scope of this, but just suffice to say, if you ever take a log and just try to light it on fire, yeah, good luck, right? That's not how you start a fire. You start it with kindling and paper and things like that. It's the furniture, interestingly enough, that burns in the buildings, but the mass timber doesn't catch on fire. And in fact, I was talking to a guy in the fire department in New York when I was in Brooklyn working on a 8-story CLT project that was kind of under the radar. I don't know how that happened, but anyway, it was a Passive House certified CLT project there, and he was really stoked about it because he says, this increase in wood construction, he said, as firemen, when we go into a steel building, we don't know when the floor is going to collapse. But with solid wood, you have a very specific clock. You know exactly how long it's going to take. There's been a lot of research done into that. It's actually one of the advantages of full dimensional lumber over like TGIs as well. So air leakage testing is becoming more and more common. We do that here locally, and that's becoming more in the code as well for good reason. And not only does it help to have continuity in that, it helps to have continuity with your water-resistant barrier as well. So oftentimes your WRB is also your air barrier. And self-adhered air barriers are critical with mass timber, CLT in particular, because if you've ever seen liquid applied air barrier membrane to OSB or plywood, one of the things you'll notice is unless it's absolutely perfect, and usually it's not, the mill thickness, etc., and even in some cases when it is, you have to pre-treat the joints first of all and everything. But as the wood moves and cracks and different things, and even on this mock-up you see here with the southern yellow pine, see in the U.S. we actually don't edge glue the CLT. In Europe they edge glue the members. We don't do that in the U.S., and those expand and contract pretty significantly, and so you don't want to. In fact, actually, the Redstone Arsenal, I believe, went with a liquid system originally, but then all the rest of the hotels that Lend-Lease built after that used a self-adhered permeable air and water barrier, and that's the way to go with when you have CLT walls. Here's an example of the one in I think this was Fort Drum up in upstate New York. That was pretty cold when they were putting that one on. Yeah, that's one of the hotels. There's several of them on military bases all over the country. Why do you think they used them on military bases, by the way? Yeah.
I think I saw this very project
Yeah.
at Greenville in Atlanta 2019,
Uh-huh.
and the one thing I remember was bomb blast.
Exactly. That's right. Blast resistance. And there's a video on YouTube of them doing testing of CLT panels. It's phenomenal. You see the shock wave go through the wood. Whereas with a concrete wall or CMU, it would actually break it. So it absorbs the shock. They could actually, and it actually had, it's kind of funny, but it had to do with parking, right? When using mass timber walls on the military bases, they could reduce the parking lot distance from 300 feet to 75 feet. So that's because of the blast resistance. That's how much more blast resistant it is. Yes? You know, I don't. It's basically just not necessary to pass the structural standards that are required here. So, yeah, is my understanding of it. And, you know, it's just more expensive to do. I think it's also a manufacturing limitation as well. I mean, the manufacturers right now are having trouble keeping up with the demand. It's wild. So this is Smartland, by the way, is another great manufacturer. And the sample that I sent out is from them. They're out in Dothan, Alabama, and they do tours, and I highly recommend visiting that. Sterling does as well. They're both great manufacturers. We've got quite a few popping up, and a lot of the European manufacturers are actually setting up operations over here, like Binderholt's one of the larger ones. And thank you. Please do ask questions anytime. And yeah, go for it. Yeah.
You said several times now that we can't keep up with the demand
Mm-hmm.
for various types of mass timber.
Yeah.
Where's the demand?
The demand is coming from large buildings. So, for example, and I'll show a few of them at the end of this.
Practically the United States.
In,
'Cause
yeah.
in Atlanta, besides T3, the Commuter building,
Yeah.
and what Jamestown is building, what else is coming up that's sizable in Georgia? I couldn't name it.
Yeah, I don't know offhand, but I am familiar with those. But I know that if you look, and I'm talking with other like DPRs looking at, got a couple coming up, and I was just talking with Niles Bolton down there last week. Gave a presentation similar to this for them because they're trying to get into mass timber as well. So it's on the design side, it's really that we're really seeing those come. So not everything hitting at once, but right now we only have about a dozen manufacturers, which is double what we had 2 or 3 years ago. And so it's really ramping up. So a lot of stuff's in design right now coming up. So real quick with mass timber walls, and again, this is only probably 20% of the market. You're not seeing as much walls, but it's a great way to build. There's lots of different ways to do the cladding attachments. This is a common one here, is seeing this just long screws, essentially making compression trusses with the exterior semi-rigid insulation. Clip and rail systems are also another way, a lot of times using thermally broken cladding attachments again. And Z's or hat channel, whether they be vertical or horizontal. But just a quick note on horizontal ones in general, you should have shims behind them, and they should be solid shims so that you have unimpeded vertical drainage. This is a very helpful thing whenever you have a horizontal cladding attachment, especially in freeze-thaw climates, because that can create a damming effect up there. And there's been some good articles written on that in the past. So just a note. And it doesn't take much, 1/8 of an inch shim. And we have these self-adhering shims that pop right on there that you can take a 1/4 inch lag through without any problem. No pre-drilling needed. So this is just something to note there. And that's whether it's mass timber or anything. In fact, one of the things you see sometimes in mass timber is also nail base polyiso as well. That has passed some NFPA 285 testing as well with fire. So it's not always mineral wool, but a lot of times it is. So just a note there. Don't neglect your window details. We actually have an entire presentation on that I highly recommend. This is #1 litigated construction defect. Don't get rid of that head flashing right there. That's key. All right, just keep that in there. Just to touch on that. Penetrations are pretty easy, liquids, so we kind of take a hybrid approach. I really think that hybrid self-adhered with liquid detailing is a great way to go in general. Base of wall, these are just some, I'm going to just kind of blow through these quickly to get to more pretty photos because we have these all in our design guide, and you're welcome to have a copy of that if I have any here. And it's also online as well, both at our website and at RDH's website. And this was a collaborative effort. But I will show you here, as you astutely noted, this is a very tricky detail here. A lot of times we want to even expose the CLT underneath so we can see that. If you go onto Clemson University campus, check out the Andy Quattlebaum building. It's beautiful. Cooper Carey designed it, and it's a absolutely phenomenal building. But it's got a lot of exposed exterior wood. It's going to be really interesting to see how that holds up. I'm very curious about the finishes and the technology and how it's going to hold up on the exterior. We're really pushing it and seeing how it's going to go. Same with Auburn University. Actually, I was just down there speaking at the conference down there that we had. I don't know if any of you made it down there. It was excellent, but they have a new building right there as well. Same architect as well, with quite a bit of exposed, but it's holding up well so far. We'll see how it goes. They say like a 3 to 5 year maintenance cycle with it is what they anticipate. Here's an example of polyiso on a roof. This is actually the same assembly that we did down in Miami. And funny enough, Miami-Dade didn't believe that our membrane was permeable because it was self-adhered. And so they wouldn't allow it to be used over the plywood. They required a mechanically attached membrane, even on a flat roof. It was kind of funny. But hey, that's Miami-Dade. They can do whatever they want. So, but we got it on the deck. They understood that they just, accepted that mass timber was new to them, and that maybe we knew what we were doing with protecting it. So at least we got that on the CLT. So here's another example. Parapets can be pretty complex as well. There's a lot of different materials, a lot of different things coming together. Mass timber is ideal for panelization. With panelization in general, you want to still maintain shingled laps. And we have a great design guide for that on the website as well. And here you can kind of make out, you heard me mention some of the gapping that you see. This was on a south elevation up there in Fort Drum. They started installing in February or January with the wood, and February with the membrane. And it had a lot of temperature and moisture changes on that elevation. So it was really critical that they had an adhesive-backed membrane that could also take the cold as well and be able to do that. So be able to handle that. So here's this design guide. It's free online, or you can also purchase copies from RDH's website, and they'll mail them out to you. I may have a couple with me, or if any of you want some, just let me know. But that was a great collaborative effort with them. It was a lot of fun working with that team up there. And this is another one of those Candlewood Suites hotels. I'm going to skip through these. And this was, that's up in Tennessee, actually. Again, this concept of protecting the banks. One of the things I like to say with regard to sustainability and the things that we pursue is you can have the most amazing Living Building Challenge certified building that if it leaks, you're going to have indoor air quality issues, mold issues, durability issues. Your carbon calculations are going to be off because of all the repairs and all the trucks that are going to have to drive there. So you really have to take care of. And there's no substitution for good craftsmanship, good design, and good materials, and the right materials for the right buildings. And so this is really critical, that just old-fashioned craftsmanship and shingled laps is irreplaceable and is critical to sustainability. Flip side of the same coin. So remember how I said mass timber is growing and it gains this exposure, right? So I wanted to come back to this and just show you from some of the projects that I've been working on, some of the things that I see out here. So I wanted to highlight how beautiful mass timber is, and there's a lot of that out there, but there are very few people talking about some of the challenges with it. And so I'm going to open this up to you so that you can see some of the things what happens when wood gets wet. Here's an inset balcony, for example, right? There are some architectural features that you may want to reconsider in mass timber construction. They also are exterior mezzanines on this with conditioned space underneath. All right, nothing wrong with that, but you really have to pay attention to what you're doing and detail it right. Okay, so here's some examples of what we saw. In fact, T3 down in Atlanta, for example, they saw quite a bit of this. They were delayed 2 or 3 months from opening, almost lost one of the clients from it. It's a big deal to these developers as well. But what's happening is that right now in the industry, because it's been growing so quickly and the general contractors are not necessarily up to speed on how to manage the moisture during construction, what's happening is the developers are, in order to keep the costs down, they're pushing that responsibility on the GC, leaving it to means and methods. They're not letting the architects specify moisture management plans necessarily, or they're very paltry ones. I mean, I'm working on a 1.7 million square foot of mass timber project right now that hardly has any moisture management plans in place. They're trying to kind of come up with something, but you can kind of imagine why. Like, let's say the moisture management plan, to do it right, it probably costs around $3 a square foot, okay, maybe $4 to do it a square foot. You know, you multiply that times 1.7 million, and that's a pretty significant expense. But how much do you think this remediation costs? And the consensus in the industry right now is that you should just budget for remediation. And the figures that people are coming back with are around $8 to $12 a square foot. And so that ounce of prevention, right, is a whole lot, is really important for mass timber. And, you know, one of the other factors that has made some of this come is in Europe, in drier climates over there, and also, by the way, in Europe, if you've ever been to a job site there, you'll notice they wear ballet shoes, right? They kind of just, it's really very, very gentle on their job sites there. It's very clean, very tidy, very orderly. They don't beat up stuff like we do here. We don't traipse in mud and having gravel on the bottom of your feet. It's just a whole lot of different. And so the European manufacturers just tell the general contractors that are buying the material in procurement, they're just saying, well, just tape the joints. You know, just taping the joints will be good enough. You know, that'll be enough. That'll be enough to manage the moisture. But this is actually what happens when you just tape joints in a climate like the Midwest. You know, in a lot of the Midwest, for example, which is where this particular project was. Actually, it's a mix of photos from different projects, but you know, we really can avoid this very easily. And again, that's, you know, it probably is around that square foot. And actually, what we're doing now is we're getting, with manufacturers such as Vaughan Timber and Sterling, you can now order CLT with membranes on them so that they're protected from the factory. And then all you have to do is strip them in like you normally would with the European techniques. And actually, believe it or not, Sterling has such capacity that it's less expensive to purchase the materials with the membrane than any of the nearest competitors. They really are commoditizing CLT right now. It's phenomenal what they're doing. I mean, they're the largest manufacturer in the world by a factor of 4 right now in the world with 1 6-hour shift. And they're opening a second factory at the end of the year. So they'll be by a factor of 8 there with just 2 shifts. So this is clear #1 Southern Yellow Pine from Smartland. That's the difference with a company like Sterling. They see a lot of these companies, different mass timber manufacturers, they have different things that they can do. Like Vaughan Timber, for example, they'll do just about anything you want, and they have incredible. You can specify a clear vertical grain Douglas fir if you want on the interior of them. I mean, it's phenomenal, and they're very responsibly managed forests as well. So lots of different manufacturers out there that can do different things. Sterling is focusing on multifamily, mixed use, and kind of medium-sized projects, and they're really aiming at concrete. And they are not concerned as much about getting #1 clear. They're just doing #2 for everything and cranking them out and selling them as fast as they can. So they're getting it out there. They've been doing it for oil exploration and for utility mats for a long time to take heavy equipment in sensitive areas. And so they're very experienced with that. So this is essentially the moisture management plan that ends up happening on most projects right now. And so we're trying to kind of get it into specifications. Division 1, Division 6, and Division 7 should all include some sort of language for moisture protection to help this along, to help us get over this hump. Maybe we can refine that as we go. We're talking with CSI, we're talking with Skip and with Woodworks, and Woodworks is coming out with their own Division 6 guide specifications right now. We went ahead and just preempted it and published Division 1, Division 6, and Division 7 just so you can plug those in and help that out hopefully a little bit. Because right now it really is, it's unfortunate that this kind of thing is happening, but we can prevent it. So here's some of the European membranes that are non-permeable, and I do want to show this real quick because they do have some solutions, but when you have a non-permeable membrane on wood, this is what can happen. It's really, really important that you use permeable membranes, moisture vapor permeable on wood. In fact, look how much better the wood that was exposed fared compared to what was covered up and quote unquote protected. All right, and this is after about 2 weeks, by the way, and this is after about 4 years under a non-permeable peel and stick. So that's structural failure. That clouding is moisture vapor, that dark is microbial growth. And that raised grain that you can see there. It's very important that we let wood permeable. So here's just a quick illustration to show you how much water can be in a building and how much can be diffused through a building envelope. And this is actually it took us about a month to really do all those calculations and get this graph in order and make sure we were correct about it. So this is over 100 hours, just a 50,000 square foot building, and that's how much moisture vapor can be diffused with a 50 perm membrane, approximately. And it's not linear. And I've actually got I took some of this data, and Oak Ridge National Labs with Air Barrier Association published a very helpful tool that you can do that actually does the calculations for you automatically based on the size of your building and where the climate is, and you can actually calculate for yourself just through air leakage how much moisture, and that's a whole nother factor altogether. And I have it's kind of a marketing piece, but I've got a whole page of footnotes that you can look at out there that is a value proposition document about why it's important to invest in your building envelope up front and do it right to begin with. Yes. So that would represent, for example, most of the membranes that are marketed as permeable are around that range, and then they use a primer which cuts it in half, if not more so. And so you end up with something below 10 perms most of the time with those types of systems. And in fact, there was one manufacturer who went so far as to publish a white paper on why 10 perms is the sweet spot. That happened to be the limitation of their technology. But of course, he had a PhD, and so he published a paper on that up in Canada. And I mean, it's just, I don't understand why, if you're keeping bulk water out and you're managing the air movement, why would you not want as much drying potential as possible? All right, and that's all that perms essentially discuss. That's what they articulate to some degree. There's a lot more to it. We actually are trying to improve the testing, taking food film technology testing to do dynamic drying, dynamic permeability testing, but that's a whole other subject. So this is just a snapshot of that study that I mentioned. Happy to email this to anyone, but the reference is up there as well. They checked 200 measurement points, and half had some growth and about a third had moderate to extensive growth, microbial growth on CLT buildings. And they concluded that it's critical to protect from weather. In fact, some buildings there are some buildings, large CLT buildings in Canada, that have had to be tented and delayed 4 to 6 months from opening just to dry them out because they didn't manage it well during construction. So it's really important to plan for that and have a good moisture management plan. I also have some sample moisture management plans that have RDH and others have come up with that can be very helpful as well if you want to take a look at those. This was a 500,000 square foot project in Cleveland, Ohio that was just opening up now. About 300 units. I'm pretty sure they're all occupied now. It's it's all mass timber with metal stud and gypsum exterior. This is kind of with post and beam construction of glue lambs. That's the most common thing that we're seeing. This is the project in Miami, Florida. Okay, and here is a technique for when we manage the moisture on the horizontal for the floors as they go up. We want to overhang that. So that's just a technique, and here's what can happen. This is actually an image from someone else's presentation that I saw from a project in, I think this is in Boston. And you can see that, if you can make that out up there, all that discoloration. So it's really important to also get good techniques. You might recognize that one there, Rob. Getting the squeegee off of there. So, and Joe. One of the cool things about this technology is the wood can be wet when it goes down, and it can still dry through it, and it will fully adhere. And so we're really happy with how that's turned out. What's that now? Yeah, it'll adhere as it dries. So it becomes adhered once it dries, but it dries through the membrane. Yep, exactly. So here's some other mass timber projects where we were doing the floor protection. So basically, let's say you have a 9-story building like that one up there in Ohio. Best practice for something that large is probably to protect every floor. If you're in Arizona or Colorado, maybe every 3rd or 4th floor, depending on what time of year it is. So it just depends on the climate. There's different strategies that can be done. Column protection is also very important, and we use an air permeable material for that. And I have some samples of that out there as well. Again, same concept of protecting the bank. You can also, I mentioned panelization as well. This was actually Katerra's facility, rest in peace. You may have heard of them. There are other manufacturers that have come up and are improving on what they were trying to do, but there's a lot of potential for both off-site and on-site construction. So this is actually a project in Austin, Texas, where they installed membrane on-site prior to it being boomed into place. And so that's another great approach as well, whether it be in the factory or in the field. Some photos of that. So coordination is key. This was a nice little project we did up in Nashville in 2012. Collaboration. This is how we get these done. So here's a bank in Hillsboro, Oregon. Some offices, just a few projects here. Upstate New York, 2017. Atlanta, Georgia. I don't know if Jennifer Bonner, I believe, is speaking on Thursday here. If any of you are attending the conference, she's fantastic, very inspiring. She really leverages architecturally, geometrically, what you can do with CLT. I will say that these fasteners right here that were like 20-inch long on that compound angle were a little bit challenging to set. So a few lessons learned. I think they each stuck up like an inch or so. They didn't pre-drill for them. So a lot of lessons, but beautiful building. This is in Inman Park in Atlanta. A very nice project. Another one in Colorado is a different building. Class A office space. Tacoma, Washington, Joint Base Lewis McChord, another one of the Candlewood Suites projects. This was actually Katerra's last hurrah. This is Michael Green Architects. Beautiful, turned out to be absolutely beautiful inside when they were done. It was supposed to be their offices. I'm not sure who the tenant is now, or the owner for that matter.